Hello everyone. So today we are going to discuss on simulation of impulse voltage generator. The contents of the presentation will be, first we are going to start with introduction, and then we are going to discuss about the objectives of this presentation. Then we'll move towards theory and then procedure and simulation, followed by some demerits and merits, and then application. And then we'll end it with a conclusion and references. So the presentation will be given by four of us. Introduction. Impulse voltage generator. So what does impulse voltage generators do? Impulse voltage generators are designed to generate impulse voltages that simulate lightning strikes and switching surges. These are some photos of impulse voltage generators. In the field of electrical engineering, high voltages are required for several applications. For example, electron microscopes and X-ray units, which require high DC voltages. So you must have seen the X-ray units. This picture depicts the same. This one is the particle accelerator, which are used in nuclear physics, which uses high DC voltages. High AC voltages are used in the testing power apparatus. Some of the objectives of this simulation model is to study the measurement of spark over and withstand voltages of various test objects, to study the behavior of output impulse voltage pulse, to enable safe setting up of the experiments, testing of high voltage devices like lightning arresters, fuses, different types of surge arresters. Further part will be explained by Nikhil.
Thank you, Shreyas. Now I'm going to elaborate about the theory of impulse voltage generator. As we have seen that the impulse voltage generator is used to produce very short or high voltages or high current surges, and it can be differentiated between impulse current generator and impulse voltage generator. So as if we perform experimental investigations, the wave have a rise time of 0.5 to 10 microseconds and decay time about 50% of the peak value and the order of 30 to 200 microseconds. So that's why due to these experimental investigations, the wave shapes are arbitrary constant and mostly unidirectional. So it is shown that the performance of the lightning over voltages can be represented as a double exponential waves in the impulse voltage generator. So yeah, next moving forward, the point is that the impulse voltage generator circuit needs at least one large capacitor that is changed to an appropriate voltage level and then discharged by a load. So suppose if we use reference purposes for that impulse voltage generator, it will be in the above circuit that the CS is the charging capacitor. So yes, now moving forward to the next slide. Hello. So yeah, the slide is all about the YouTube video links we used for the relevant information about impulse voltage generator. The links are the following ways. In these links, we use some relevant information about impulse voltage generator, like the topics we used and the relevant information about the simulations we perform on the virtual labs and some of the techniques and as a references. Yeah. So these are the components we use for the impulse voltage generator circuits. The first one is resistor. The resistor we use for the impulse voltage generator is the rating of 10 to 100 kilo ohm, and the another one is a spark gap and generator capacitor. Spark gap is used for to generate high voltage supply, and it can be used as a high voltage supply between the plates, and the voltage across the gap rises until it sparks. This is the working function for the spark gap and generator capacitor used in the IVG. Then we use voltage dividers. It is used for to turn a large voltage into smaller one by using some resistors and an input voltage. Also, we can create an output voltage that is the function of input. Then we are just replacing the referring gas impulse generator to refer some points for to simulate impulse voltage generator reactions in the practicals. Then triggering system then we use triggering system to go for IVG to turn on some internal electronic devices and also for communicate it. It can be achieved in many ways by using some triggering techniques like commutations and cell commutation techniques to turn off it, and some triggering techniques to turn on the some power electronic devices used in the impulse voltage generator. Then we are using DC charging set for associating DC voltage in the addition loading while performing the practice on impulse voltage generator experiment. So yeah, this is the procedure we follow for to simulate the impulse voltage generator on virtual lab. Such as when we open virtual lab, then we have to page the load as per presented with the 3D simulator on the representation of IVG with the right frames. Then we just hover the mouse on the equivalent circuit to see the equivalent circuit diagram for the simulator model, because we have to perform the simulation of impulse voltage generator as per the circuit diagram showing on the virtual lab experiments. Then we have to follow the instruction to know how to perform the experiment, to how to perform the simulations for that particular impulse voltage generators. Then we have to name the input parameters like the VO, that is the charging voltage, the ground capacitance, which is terminated as a CG, tail capacitance, which is terminated as a CI, the front inductance LF, the road inductance LI, and the front resistance RF. Also, it is displayed with the default values on the other frames. The another point is that we just conduct the experiment with the default values. However, the parameters can be also changed by some experiment performance, but just we have to differentiate with the constant values and default values. Then we have to just drag the mouse on the impulse voltage generator circuits, and we have to test the apparatus in details. Then we can also zoom in it by scrolling your mouse for details study of IVG, because on that virtual websites we have just so many points and so many clicks. Then we just scroll the mouse and we are just finding so many detailed study about the impulse voltage generators. So after completing the detailed study of IVG, we have just set the value of voltage and sphere gap according to our requirements or as per our need, and then we are just taking a flash over to perform some simulation techniques on impulse voltage generator. Yeah. So yeah, after that, following the procedure, we are just clicking on the start experiment. We are just clicking on the start experiment to perform simulation and also to demonstrate the practice on the impulse voltage generator. Like suppose we are clicking on open ground switch to give supply to IVG, and then we are just saying it in an simulator. Then we are charging the capacitor button is to be clicked, because we have to charge the generator capacitors to display the bar on the network of the simulator. After that, we are just displaying the mechanism of impulse voltage generator to breakdown is to determine the breakdown which is occurring and not occurring. After completing the breakdown process, we are just after completing the breakdown process on voltage laboratory, V labs, then we are just completing the process of respective graphs, because after completing the simulation, the V lab will showing the respective graphs according to our voltages and current ratings. After that, we are just fetching the direct user statements with the flash over to withstand whether the gap is occurred between the sphere gaps or arc is kept between the sphere gaps. So yeah, the waveform is changing with the variations in parameters, and it can also different and also we can get different waveforms as per requirement for the generated withstands. So yeah, we are moving to the next slides. Yeah, so this is the photograph or the image of simulation we perform on the virtual labs, and the link is all about the impulse voltage generated simulations on the virtual labs. From that link, or you can also use the link to watch that how we perform our simulation on the virtual lab by taking some parameters and giving as per your requirement ratings as a voltage and also your dielectrics in the material. Yeah. So yeah, moving forward to the next slide. Yeah, so this slide is all about merits and demerits of impulse voltage generators. Now I would like to change the direction and to call my fellow partner Akash. So yeah, over to you, Akash.
Everyone, this is Akash Patil. Let us discuss what are the merits and demerits of impulse voltage generator. So let us discuss merit first. Voltage impulse generator have very high repetition rate. It has very high reliability, and it's easy control of an output voltage waveform. It also has very high efficiency, and it is used for flash X-ray generation. Now let us discuss what are the demerits of voltage impulse generator. The major disadvantage of impulse voltage generator is its physical size. Depending on the high voltage rating, the components get bigger in size, and so components get bigger, its cost also increase. Also, the high impulse voltage generator requires a high DC voltage. So for a single stage impulse voltage generator circuit, it gets quite difficult to get optimum efficiency even after using large DC power supplies. So loss of efficiency is there. And the third disadvantage is the spares that are used for gap connection also requires very high in size. So the corona that is gets discharged by the impulse voltage generator is very difficult to suppress and reshape. So the electrode's life gets shortened and requires replacement after few cycles of repetition. It has very long charging time and the short lifespan of the spark gap. And as we discussed above, it has very there is a loss of efficiency there. Over to Caroline. Thank you.
Talking about the applications of impulse voltage generator, it's used in a variety of fields. For example, lightning testing on cables and insulators, material and dielectric testing, current injection and generation, flash X-ray generation, nuclear electromagnetic pulse generator, generation of plasma focusing, remote deprogramming of processors used in computers and other control circuits. So to conclude this experiment, the simulation circuit closely approximated the actual base impulse generator. The resistance value of the stage front resistor also had an impact on the time to peak. And in actual impulse generator, this value is actually adjusted to correct the time to be in tolerance. The peak voltage was also well within tolerance and closely approximated the base impulse generator. But one of the major problems observed in high voltage field is the testing of HV equipments in the lab. The voltage ratings of the different equipments are different, which is why it requires different rating high voltage impulse generators and the associated equipments. Hence, it's a difficult setup than those done practically. These were a few reference books that we referred to as a team and also a few YouTube videos which you all saw in slide number 10. First and foremost, I would like to thank our mentor and guide, Professor M.H. Thind, for guiding us, supporting us, and making this assignment as creative as possible, helping each one of us find our creative skills. Also, I'd like to thank each and every team member who worked hard to make this assignment a big success. I would also like to thank the viewers for viewing and commenting on this video. I also would request y'all to drop in your doubts if y'all have any in the comment section below. Thank you all.